Hello everyone, this is Miss Berlin and welcome to Crack Physics Sessions. I have mentioned this before that we will be conducting scheduled Crack Physics Sessions which will or stands about computation, reasoning, and applying core knowledge. This Crack Physics session is to enhance, discuss essential topics in physics or advanced topics in physics that is not covered in the curriculum. We mean to say university level sessions. But then, on this session, we will have the essential topics in physics, particularly in kinematics that we will cover. And on that note, we will be discussing or we will be learning together about free fall motion. So to start the lesson or to start the session, we will have here two pieces of paper. I want you to get two pieces of paper. One is straightened, flattened paper, and the other one is crumpled paper. So which will reach the ground first? What do you think? Can you do that? Of course, in this earth, the paper that will reach the ground first is the crumpled paper, right? Now, how about if you will neglect air friction? I mean to say, with the absence of the air, do you think these objects will reach the ground at the same time? Okay. So remember that free fall is the motion of an object under the effect of gravitational force only. So mean to say these are motions are applicable for vertical motions. So for example, if you throw an object upward or downward, the object will always return on the surface or center of the earth, meaning to say that that object is subjected on the presence of gravity only. Okay? Now, I'd like you to ponder on these two questions. Do heavier objects fall faster than lighter ones when starting from the same position? And number two, does air resistance matter? To answer those questions, we will go back in 1971 when astronaut David Scott performed the hammer and feather experiment in his flight in Apollo 15. So this experiment was inspired by Galileo in the Leaning Tower of Pisa, where he constantly threw two different masses of rocks. For example, we have here the red heavier and the other one is the lighter rock. He throws that in the ground and then he came up with a thought experiment that what if there is no air resistance? Will these two different masses of rock fall at the same rate? And he answered that yes, it will fall at the same rate considered if the object is at the vacuum. That is his thought experiment by Galileo. Now, according to him, without the air resistance, two objects of different masses will fall at the same rate. And does air resistance matter? We will answer that on this definition. What is air resistance? The air resistance is the force of friction or drag acting on an object if the direction opposing its motion as it moves through the air. So for example, you throw an object downward, then air resistance is the opposite of that object's motion. So if the object is downward, then air resistance is the opposite upward motion. So even if you have a lighter paper compared to the crumpled ones, in the presence of air resistance, the crumpled object will fall faster compared to the lighter ones because the paper is being opposed by the air resistance upward as it falls. Now, balik tayo kay David Scott. According to David Scott on hammer and feather experiment, in the presence of air, which will fall faster? Is it the feather or the hammer in the presence of air resistance? Of course, hammer will fall first because of air resistance. But when David Scott performed this experiment in the moon, he actually performed this experiment in the moon with the different masses, he observed that the different masses will fall at the same time despite the difference in their masses. So again, without the air resistance, all objects will fall at the same rate. Now, I'd like you to think of this. If the free fall motion has a constant acceleration, what is this acceleration and how was it found? To answer this question, we will conduct the simulation. To simulate, I have here a simulator, of course. Let us drop this object at 130 meters at the same height. 125 meters rather. So, let us drop this. Observe how fast it will fall to the center of the earth. This is the time. So on Earth, this ball will fall at will hit the ground at 5 seconds. How about on Jupiter? On Jupiter, that has a gravity of 24.79 meters per second squared, but on Earth, that is 9.8 meters per second squared. So meaning to say, the difference in the acceleration due to gravity on the value of this one is that the Jupiter has a massive acceleration due to gravity compared to Earth. So let us drop the rock or ball, whatever. So compared to Earth, the rock fall on the ground faster compared to Earth. It's 3.2 seconds compared to the Earth's 5 seconds, right? So meaning to say, the object will fall faster to Jupiter, and the Jupiter has a greater acceleration due to gravity because the planet is more massive. The more massive the planet, the faster an object will accelerate. Okay? Mas greater yung force ng gravity compared sa other planets. Now, let us go back on our slide. Let us try solving the sample problems related to free-falling bodies or free-fall motion. So we have these practice problems and these practice problems, and I'd like you to watch this, how you solve this one.
Now, for sample problem number 1, I have here related to the topic, a tilapia is dropped by a hovering eagle. How far will the fish fall in 2.0 seconds before the bird catches it again? We have to neglect air friction since this is a free fall. Alright, so the problem here is dropped by. So you will have a positive 9.8 meters per second squared. Let us specify the given values. We have here the given values of initial velocity of 0. It is not specified here. Alright. And then time at 2.0 seconds. Acceleration due to gravity at 9.8 meters per second squared. That is positive because it is dropped and it does not oppose the gravity. The solution here is this one. Since you are being asked to find how far it is distance, how far from the fall, this one, the height here, drop. So we are looking for the distance since the drop of the fish. So you will have here, distance is equivalent to the product of initial velocity and time plus the acceleration due to gravity times squared over 2. So substitution lang kayo, you will have here, the initial velocity is 0, time is 2.0 seconds, so automatically 0 na yan. And then you will have here, the acceleration due to gravity is 9.8 meters per second squared, time is 2.0 second, and then that will be raised to 2 over 2. And then, you will have 9.8 meters per second squared. Square that will be 4 seconds squared. Square as well the variable here. So, cancel the second unit. Cancel the second squared. You will be left out with the meter unit. And then you will have 9.8 times 4 over 2. You will have 19.6 meters. Then, sample problem number 2. A pitcher tosses a baseball straight up with an initial speed of 15 meters per second. Letter A. How long does it take to reach its highest point? And letter B. How high does the ball rise above its release point? So, you will have here now the initial speed of 15 meters per second. And how long? We are looking for the time. So, for given values, we have here the 15 meters per second for our initial velocity. And then, we have the final velocity of 0. Why? Because here you have how long does it take to reach its highest point. Because the velocity or the speed at the highest point, as always, the maximum point at above is 0. Okay? At the lowest point, that is 0 as well. So, on this case, we will be using the 0 value since we are pertaining to the highest point of the distance since it has been tossed upward. So, pataas to pataas yung tapon. So, ang magiging value ng acceleration due to gravity mo rito ay negative. So, yes, you have here the negative value because it was tossed upward or tinapon pataas yung baseball. Now, let us answer problem A. How long does it take to reach its highest point? This is the formula that you will be using. Alright, so you will have substitution. Time is equivalent to the final velocity, which is 0. Initial velocity, which is 15 meters per second, over negative 9.8 meters per second squared. And then cancel the second unit, law of sine, 2 minus 1, that will be 1. You will be left out with meters per second squared. And then, perform the operation here. Perform the operation. You will have is 1.53 seconds, meaning it will take 1.53 seconds to reach its highest point. Now, let us proceed on letter B. how high does the ball rise above its release point? Nung tinapon na siya, gaano kataas daw yung narating niya from the highest point? How high siya pinakawalan? Alright, so you will be having this formula here, distance, when we pertain to the upward movement. Kapag pataas, ito yung formula na gagamitin natin for distance. So you will have here 0 for final velocity, square, automatically 0. So next, initial velocity minus 15 meters per second over raised to 2, and then over 2 acceleration due to gravity of negative, and then square this one, meter squared, second squared, because you square the value here of initial velocity, and then you will have 225 here, that is negative, and then multiplied 2 and negative 9.8, you will have negative 19.6, then cancel the second unit, then 2 minus 1 for meters, law of sign, you will have a meter unit left, and then you will have to divide this one, you will have 11.48 meters. This is the answer for the distance.
And that concludes our lesson. Goodbye and good luck, and see you in the next Crack Physics sessions.